In lesson 7, we are going to talk about the angle side angle triangle congruence. So we're going to see if we can prove other sets of measurements that guarantee triangles are congruent. If you remember back to yesterday's lesson, in lesson 6, we proved that triangles are congruent if we only know two sets of sides are congruent and the angle between them. So today we're going to be looking at two angles with the side between them. So first we're going to take a look at this assertion. So you can just read it on the screen and then talk about a couple of things that you notice, at least one thing you notice, and at least one thing you wonder. So the assertion says through two distinct points passes a unique line. Two lines are said to be distinct if there is at least one point that belongs to one but not the other. Otherwise, we say the lines are the same. Lines that have no point in common are said to be parallel. Therefore, we can conclude, given two distinct lines, either they are parallel or they have exactly one point in common. So some things you might have noticed after reading that is that it's about lines. Okay, they talk about lines. You might have also noticed that they talk about parallel lines. You might have also noticed that they talked about two lines are either parallel or they have one point in common. Maybe you wondered, why is this important? Maybe you wondered why couldn't they have more than one point in common? Okay, or what does a unique line mean? Okay, so these are just a few things that you could have noticed and wondered in reading that assertion. So this is kind of what it looks like. And so as long as there's at least one point on L that isn't on M, then they're different. They're unique. Okay, they're distinct lines. If they shared all their points, they would be the same line. And if they didn't share any points, then they would be parallel. Okay, so if we had this one in comparison to M. So they don't share, and you can't find any points in common. Okay, so either they're parallel, they have one point in common, or they're exactly the same line. All right, then in 7.2, so in your workbook, first you're going to draw two congruent triangles and describe a rigid motion that takes one triangle to the next. Then you're going to write down a plan to prove that they're congruent, and then we'll talk about it. So when you're drawing your two triangles in step 1, you have to make sure that this information is true. So you need to have angle W congruent to angle D, angle X congruent to angle E, and angle WX congruent to DE. So I would start first by drawing the side and defining how long you want that side to be. So using a ruler. Then you can label it, and then you can draw the angles on, and then repeat for the other triangle. Once you've gotten those drawn, then describe a sequence of rigid motion that takes your first triangle, WXY, onto triangle DEF. So I'm going to start, and I'll just draw it. If you don't need to watch this part, feel free to fast forward if you know how to do this to be drawing your triangle. So I'm just going to start with a segment. So I'm going to draw a 5 centimeter segment. Okay, then over here I'm also going to draw a 5 centimeter segment. And then, let's see, did I draw a 5 centimeter? Yep, okay. So then you're going to need to label. And so we wanted to have WX. And then we wanted that to be congruent to DE. Then we wanted angle W to be congruent to D. So we're going to get our protractor and just, you can decide whatever you want for the angle. Okay, so I'm just going to draw it dotted on my screen. If I was drawing it in my notebook, I would be doing it with just like kind of a light pencil mark. So I'm going to do my angle W 30 degrees. So then that would mean that I'm also going to do angle D 30 degrees. So I would just write this in my, on my triangles. And then you're going to measure angle X. Okay, so again, you get to decide whatever you want for the measure of this angle. Okay, I'm going to do a 100-degree angle. And then that would mean that I'm also going to do a 100-degree angle for E, since those need to be congruent. So again, I'm going to label that on my picture. So this is 100 degrees, this is 100 degrees. And then you can kind of see how your triangle has formed now. So now you can fill in or do the rest of the sides. So I'm just going to do this in a different color than the red because it is not something that I measured. So I didn't actually use a ruler to find these sides. Okay, so I'm just going to draw those in kind of a different color here. And so then you have your two triangles. And then, so this was WXY and then DEF. So describing a rigid motion for mine, I would say I'm going to translate triangle WXY by directed segment. WD. Okay, so meaning I'm going to move from W to D. And then since now W would be on D, then I'm going to rotate triangle WXY around point D, the one that we have together now. We moved W to D. So I'm going to use that for my center until point X coincides with E. So what I've done now is I've shown that W lands on D. Okay, so we've gotten W to go to D through a translation. Then we rotated around that, leaving it the same, and got X to go to E. So kind of the question mark here is, will Y land on F? Okay, will Y land on F? So we know we started with this as a 5 centimeter segment and this as a 5 centimeter segment. Okay, and then we've got these angles the same. So will Y land on F? And that goes back to our assertion from the warm-up. So when we do move this triangle, okay, and we do rotate it on here, we do know that Y's image, okay, the image of Y will be somewhere along this ray. Okay, and I'm just going to change this one's color to purple maybe so that they're different colors. So we know that Y will land somewhere on this ray because these two angles are the same. So we know they're on this angle because the angle extends forever, right? So I know that Y is somewhere along this 30-degree angle. And then similarly, since we've got X matched up with E, so we've got a 100-degree angle here, we know that y will land on this ray as well, okay, on this 100-degree angle. So I know that y is on this one, and I know that y is on this one. And there's no way for two lines to intersect at two different points. They can only intersect at one point. So those two, the image of y, okay, since it's on both of these rays, has to land on F. That's the only spot for it to land. So this means that angle side angle, if you ever see two triangles that have two angles marked up, okay, congruent to each other, and the side in between them, these have got to be congruent. There's no other way for it to happen. So that's kind of your plan for your proof, okay? So in making a plan for your proof, so you're going to prove that you can bring X to E. You need to prove that you can bring W then to D. So we're going to translate, okay, translate the triangle to get one set of vertices matching, rotate to get a second. And then since these two angles are the same, we know Y has to land on F. It's the only way possible since two lines can only intersect at one point. All right, then in 7.3, you're revisiting parallel lines. Okay, so we have two parallel lines, and if you remember when we talked about parallel lines, we kind of talked about them in two different ways. Okay, so we talked about that we can translate this set of angles down. Okay, so if we translate any angle that lands on top of each other, those are called corresponding. Okay, so if we grab this and move it down, B will land on F, A will land on E, C will land on G, and D will land on H. So those are called corresponding angles, angles in the same relative position when you do a translation and they land on each other. So these are called corresponding angles. And we know that they're the exact same size, so we know that they're equal to each other. Another way we looked at parallel lines was by putting finding the point right between the two parallel lines on what's called the transversal. So this is called, this line in the middle here is called the transversal. And so we talked about rotating, okay? If we picked this up and rotated it 180 degrees, okay, grabbed all of these angles and rotated them 180. The angles on the inside of the two parallel lines, okay, so between the two parallel lines, so if I rotate this, C would land on E, D would land on F. So through a rotation, the angles that land on each other between these two parallel lines, okay, so in between these two parallel lines, those are called alternate interior angles. Okay, and we also know that those are equal to each other or congruent. So we've got that set like C and E in the picture, or this set D and F are called alternate interior. The ones outside of the two parallel lines that land on each other are alternate exterior angles. So if we take a look at this, okay, then we can fill in all the missing angles here. So we know if this one is 42, the one across from it is 42. Those are called vertical angles. Next to each other, okay, so this makes a straight line, which is 180. So if we do 180 minus 42, we would get 138. So this one would be 138. This one would be 138. We can translate these all down. So then F would be 138, E would be 42, H would be 138, and G would be 142. Or sorry, 42, not 142. So this next activity we're going to take a look at, we've got quadrilateral ABCD is a parallelogram. Okay, so I'm just going to quick draw that, just do a sketch over here for you. So A, B, C, D is a parallelogram. By definition, what a parallelogram means is that AB is congruent to CD and BC is parallel to AD. Okay, so AB is parallel to CD, BC is parallel to AD. So what I want you to do in your book is sketch a parallelogram and then draw an auxiliary line that splits this parallelogram into two congruent triangles. I'm suggesting you do it from A to C here, but you can certainly do it from B to D. It does not matter. Just split it into two equal triangles. So then what we want to do with this is we want to come up with a plan to prove that one pair of opposite sides in the parallelogram is congruent. So one pair of opposite sides in the parallelogram is congruent. So we already know that they're parallel, okay? So thinking about that, so they told us, remember that we've got parallel sides. That's the definition of a parallelogram, is that opposite sides are parallel. But what we want to do is prove that one of the sets of sides is congruent. You can pick what set of sides you want, okay? It doesn't matter. So I'm going to look at trying to prove that AB is congruent to CD. You could certainly do BC and AD if you wanted. Okay, just prove that one set. Okay, so what I'm trying to prove, what my goal in my proof is to prove that segment AB is congruent to segment CD. So what I'm going to do to prove this is if I knew that these two triangles were congruent, AB and CD would be corresponding sides. So I'm going to prove that triangle ABC, okay, so ABC is congruent to, and it looks like the angle that matches with A in this triangle is C. So I'm going to prove that ABC is congruent to triangle CDA. And we've been talking about angle, side, angle today, so I'm just going to assume that that's what I'm trying to do, is prove it by angle, side, angle, congruence theorem, because then I'd have corresponding parts, okay, because then AB matches CD. Remember, you can see that in the order of the congruence statement. AB matches CD. So then those are corresponding parts, and they would be congruent. Okay, so that's my plan. That's what I want to do. I somehow want to try and figure out how I'm going to prove this triangle to this triangle by angle, side, angle. So there's going to be various ways to do this and to talk about it. I'm just going to go through one. Doesn't have to match yours exactly. Okay, so yours could be in your words or your thinking. So I know I want to get to angle, side, angle. Okay, so I know I'm going to need two angles, two sets of angles and a side between. In the last example, we talked about parallel lines. And then we're doing another example on a parallelogram. So we're probably going to use that. Okay, so what I'm seeing here is that I've got this parallel line, I've got this parallel line, and I've got this that I could look at as a transversal. So if I look at that off to the side, okay, I can see that I see this angle and this angle. Those are alternate interior angles. Okay, so they're kind of like you could do a rotation around here and A would land on C. Okay, so angle BCA, this top one, is congruent to DAC. Okay, and the reason is because we've got parallel lines, so BC and AD are parallel, and those two angles, angle BCA and angle DAC, are alternate interior angles. That's how I know that they're congruent, because they are alternate interior angles. So then similarly, I could do that with the next set of parallel sides. So I could be looking at this line and this line are parallel. Okay, and then looking at this as the transversal again. So now off to the side, that kind of looks like this. And I see this is this angle, and this is this angle. So those are alternate interior angles, which are again congruent. Okay, so BAC is congruent to DCA because line AB is parallel to line CD, and BAC and DCA are again alternate interior angles. So now I've gotten the two angles, right? So I've got this angle congruent to this angle. I've got this angle congruent to this angle. So if I kind of redraw, let me redraw one of these triangles since there's so much going on here, okay? So much stuff that I've drawn on. So I've got this one, and I've got this one. Similarly over here, right? I've got this angle, and I've got this angle. So now we need to somehow prove the side in between them is congruent. So if we take a look at this, okay, here's this side. Okay, this side is in both triangles. So this side over here is AC. Right here, it's also AC. It's the exact same segment. So AC is definitely congruent to AC. Why? Because it's the same exact segment. It has to be equal to itself. So now that is enough, okay, because now we've got this side. So now we see two angles and the side in between. So that's enough to say that triangle ABC, okay, triangle ABC, match up the correct vertices, is congruent to CDA. And the reason for that is by the angle side angle congruence theorem. Then, now that we have the two triangles are congruent, then the corresponding sides would be congruent since we know that they are congruent to each other. Okay, we know that those two triangles are exactly the same. So side AB is going to be congruent to side CD because they are corresponding parts of these congruent triangles. So now we know all of the sets are congruent, okay? So we proved one pair of opposite sides are congruent, but that also proves the others are, okay? The other set is as well. So if we split this, right, we're going to get this angle to this angle because they're alternate interior. This angle to this angle because they're alternate interior since these lines are parallel. And then this segment is shared between both of these triangles. So now you've got all your corresponding parts. You know this side is congruent to this side. Okay, you would also know that this side is congruent to this side. Okay, so both pairs of opposite sides in a parallelogram are congruent, and that's why you'd also know this angle is congruent to this angle since the two triangles are congruent. So let's take a look at these two proofs. So these are kind of the two proofs that we've looked at over lessons 6 and 7. So this one, we see two sets of sides that are marked as congruent. So we see this side marked to this one. And then we see that both of these triangles share side BC. Okay, so segment BC is the exact same segment in the top triangle as the bottom. And then we see this angle between those two segments being marked congruent. So these two triangles are congruent. So ABC is congruent to GBC. And so that was by side angle side like we talked about in lesson 6. And then today we talked about if we know one side length, is congruent. And then the angles on either side of that. Okay, so now we see this angle and this angle. And then we see this angle and this angle. So two angles and the side between it. So DEA, okay, so match them up. So DEA, so D has no marks. So D goes with B, E goes with E, A goes with C. So those two triangles are congruent by angle, side, angle. So you can get this written in your reference chart about the angle, side, angle congruence theorem. You can also define a parallelogram, which was two pairs of opposite sides parallel. You can also write about parallelograms having opposite sides congruent. We proved that today. And then you can read over the lesson summary in your student workbook, remembering that we talked about angle, side, angle. And then we also looked at parallelograms and how to prove that opposite sides were congruent.